So for this practice, you're going to be going over things dealing with domains and ranges, recognizing functions, and average rate of change. So let's get into the problems. As usual, you'll be given a chance to try the problem. You'll be asked a question, and after you answer it, I will show you in the video how to go about doing it. So find the domain and range of this function here. Well, the domain of the function is just your, usually the x value, but this is actually a t value this time. It's the input value. You can see the input value is shown right here as being t, and it's the horizontal axis here. So basically, we want to know how far the t's can run from. And as you can look at the graph, you're basically looking to see how far left the graph goes and how far right the graph goes. So the domain would be between these two values here. And as you can see, this line goes through -7. This line goes through 8. So the domain here would be all real numbers, such that t is between -7 and 8. As far as the range goes, much the same way, we're looking for the y values, because the y is usually considered to be a function of whatever my input value was. So I want to see where the y coordinates can add up, end up being. So I'm looking for the highest point and the lowest point. Sometimes students make a mistake and they think that, I just look at these endpoints and use the y coordinates of the endpoints. It's not the case. Sometimes it might, but I'm looking for the highest point. This looks like this would be the highest point, and the lowest point would be down here. So the range would be all the values between here, because I don't have any gaps or anything broken up here. So it looks like the lowest value is -4, the highest value is 8. So the range is all values f. I have f of t, but it really should be g of t, but same idea. Such that you're between -4 and 8 inclusive. For this function here, it's very similar. You're asked to find the domain and range of the function, so take a moment, find the domain and range, and then we'll go over it. So again, the domain, I'm looking to see, this actually is an x value this time around, so looking to see how far the x values go for this graph. So as I can see, the farthest left the graph goes is -9, the farthest right it goes is +9. And so my domain is all real numbers from -9 to 9. And again, the range, I'm looking for basically where the y values go from. And it's still a y value, it's a function of x. So I'm looking for the highest and lowest points. So the lowest, it looks like it goes down to is -7. The highest is 6. So my range is between those two values. And so my range would be all real numbers between -7 and +6. Now you're going to be given this function here and asked to find the domain. So take a moment and see if you can find the domain for this function here. Okay, so basically when I have functions like this, we assume it's all real numbers until we see anything in the function that would cause possible problems. And when I have a rational function, which means I have x's that are in denominators, that's where I have my first potential for having values of x that may not work. And so a value of x that would cause a problem with this is any value of x that would make this denominator equal to 0, because I cannot divide by 0. So basically, for me to find any restriction doesn't mean I'm going to find any. I'm going to assume it's all real numbers unless I find a restriction. And, the restriction would be anything that makes 4x minus 12 equals 0. So I want 4x minus 12 to not equal 0. Which means if I add 12 to both sides, I want 4x to not equal 12. And dividing both sides by 4, it means that x should not equal 3. So basically, my domain are all real numbers such that x does not equal 3. Any other number is fine. But x equaling 3 will cause the bottom to become 0, and therefore the function won't exist. Try this one. In a very similar manner, this is still a rational function. I can see I have variables in the denominator. And if I have a denominator with a variable in it, which means this value down here can change. So if it changes, it might become 0, it may not become 0. But I want to see, okay, can this become 0? And if it does, that's a value I have to exclude. So I want to basically have a situation where 16 minus 4t does not equal 0. So, which means that 4t cannot equal 16, which means that t cannot equal 4. And so my domain for this function would be the values of t, all being all real numbers, such that t is not equal to 4. Now, there's other functions that have domains we have to look for that may have restrictions as well. The other one that was shown in the videos that you were asked to look over, we're dealing with radical functions, more specifically, square root functions. Now, square root functions have specific issues as well, but take a moment to think about what they are, try to think about what the domain for this function will be, and then we'll go over it. So for this function here, with a square root or radical or a principal square root function, I can't have anything that's negative underneath of this square root symbol. If I have a negative number underneath there, I'm not able to do this in the real number system. And when we deal with graphs, we're only talking about real numbers, altogether. So we're starting with the real numbers as our guideline for this, but will all real numbers produce values that I can work this function through? So basically, for this function to exist, this value 9t minus 45 has to be 0 or more, because I can take the square root of any number that's 0 or more. I just can't take the square root of any negative numbers. So I have to say that 9t minus 45 is greater than or equal to 0. Adding 45 to both sides means that 9t is greater than or equal to 45. And dividing both sides by 9, that means that t is greater than or equal to 5. So for this to exist, t has to be greater than or equal to 5. And so that's what my domain. Domain is all real numbers of t, such that t is greater than or equal to 5. Now try this one here and see what you think the domain of this function is. Well, here we have the 18 minus 6x underneath the radical. The minus 3 doesn't really play a role for the domain. It's more of anything that would, work with the range. But this function here, the 18 minus 6x is what's going to, be affected by the radical. So this is what has to be greater than or equal to 0, which means that, there's different ways to go about answering this, but if I add 6x to both sides, I would get 18 is greater than or equal to 6x, which is also the same thing as 6x is less than or equal to 18. Because, if I move this to the other side, the pointed end of this inequality would be facing the 6x, and it still does in this one too. And then dividing both sides by 6, I would get that x is less than or equal to 3. So for this function to exist up here, x has to be less than or equal to 3, which means that x's could be negative. The x's could be negative all they want to be, because if I have negative x's in here, that's going to cause this to become an addition, and I'm still going to have a positive value down here. So don't think automatically that x's being negative are not allowed underneath the radicals. They can be, especially in situations like this. When I start getting values that are bigger than 3, that's when this becomes negative, and this thing doesn't work anymore. So again, the domain for this function is all real numbers of x, such that x is less than or equal to 3. Now for this one here, you're asked to find the average rate of change of the function over the interval from 0 to 9. So take a moment, calculate the average rate of change on this interval, and then we'll go over it. So for this function here, between 0 and 9, those are the x values, which means that I'm looking at this point here, 0, negative 7, I should say, and 9, 3. So I want to find the average rate of change with this. Now, as mentioned on the Khan Academy videos, and although we haven't specifically focused a whole lot of attention on the concept, the average rate of change is another name for slope. I'm looking for the slope between these 2 points. So when I want to calculate the average rate of change, I'm going to take the 2 y values and subtract them, and divide that by the 2 x values being subtracted in the same order. So I can either do 3 minus negative 7 over 9 minus 0, or I can do negative 7 minus 3 over 0 minus 9. It really doesn't matter which way you do it. I chose the first way. in which, 3 minus negative 7 equals 10, 9 minus 0 equals 9. So 10 over 9 ends up being 1.1 repeating. You can write it any way you want here. 10 over 9 is also fine. But that's the average rate of change for this. Whatever these values would stand for, that's the average rate of change. And that would be basically the slope of the line that connected these 2 points. So from this graph again, very similar graph. What's the average rate of change of the function over the interval negative 8 and 2? So take a moment, calculate the rate of change for that, and then we'll go over it. Well, again, I want to go from negative 8 to positive 2, so I got to find the coordinates, on the graph that go along with it. So at negative 8, the graph of g of t is at 1. At 2, the graph of g of t is at negative 4. So negative 8, 1, and 2, negative 4 are my ordered pairs. So when I do my average rate of change, I'm going to do what's, basically the y coordinates, if you want to consider it that way. 1 and negative 4 over what's here, the t coordinates, negative 8 and 2. So that's how I can set up my subtraction. 1 minus a negative 4 is 5. Negative 8 minus 2 is negative 10. 5 divided by negative 10 becomes a negative 1/2, which is also a negative 0.5. I forgot to put the negative in there, so let me get that in there, if I can. So let's throw that in there real quick. Negative 0.5, same thing as negative 1/2. So now let's look at perhaps using some tables now for this. What's the average rate of change of the function over the interval negative 3 and 1 for this function g of t? And you have this table here, so use the table and come up with your average rate of change, and then we'll go over it. Nothing more different than we did at the graph, except, the table just outright gives you what the value you need is. I'm looking for the g values to go along with negative 3 and 1, so obviously I'm looking at these 2 ordered pairs here. And so I have one ordered pair, negative 3, 6, and I have the other ordered pair, 1, 0. Now, of course, the negative 3 and 1 are my x or t coordinates in this case. And my 6 and 0 are my y coordinates, or my function coordinates, which is really what I'll look at them. So when I calculate the average rate of change, I'm going to do a subtraction between these 2 on top. So either 6 minus 0, 0 minus 6. I went with 6 minus 0, so I chose the t's in the same order, negative 3 minus 1. 6 minus 0 is 6, negative 3 minus 1 is negative 4. This would reduce down to a negative 3/2, which is also known as negative 1.5. So that would be the average rate of change for this instance. Let's try another table. What's the average rate of change over the interval negative 1 and 3 for this function here? So take a moment, figure that out, and then we'll go over it. So again, I'm looking for the x values of negative 1 and 3 and their corresponding y coordinates. So negative 1 is corresponding with 5, 3 corresponds with negative 5. So these would be my y coordinates being subtracted on top. So either 5 minus negative 5 or negative 5 minus 5. I chose to do 5 minus negative 5, so I chose the x coordinates in the same order, negative 1 minus 3. So 5 minus negative 5 is 10. Negative 1 minus 3 is negative 4. This becomes a negative 5/2 or a negative 2.5 for the average rate of change. So graphs and tables are not that difficult in that, they're pretty much giving you the values. Sometimes the graphs might be a little tricky to guess what the coordinates are if they don't have it going through where the grid marks are intersecting each other. Although most of the examples we've done so far, they've done that. That's where having equations also comes in handy. So let's try to do this for some equations now. So what is the average rate of change of the function over the interval 1 to 6 for the function f of x equals x cubed minus 9x? So take a moment try to figure out how you'd go about doing this, and then we'll go through it. So here we have our x values, 1 to 6. For me to figure out the average rate of change, I have to do basically plugging these numbers into f of x are what's going to give me my y values. I mean, I was either looking at a table or I was looking at a graph before, but those values on the table, those values on the graph are often coming from an equation like this. So that's where they're coming from. That's how I know how the pattern is going to look. So if I choose to do f of 6 minus f of 1, I'm going to do the 6 minus 1 down here. So that means I got to go to the function f of x, replace the x with 6, and calculate what this is. Then do the same thing for 1. I got to go and plug in 1 here and see what that is. I plug the 6 in, I get 162. I plug the 1 in, I get a negative 8. So I have 162 minus a negative 8 over 6 minus 1, which is 5. 162 minus a negative 8 is 170. So this is 170 divided by 5, which is actually 34. So the average rate of change for this function over the interval 1 to 6 is 34. Let's try another one like this one. The average rate of change of the function over the interval of x between negative 5 and negative 1, where the function is g of x equals x plus 3 quantity squared plus 5. So take a moment, calculate the average rate of change, and then we'll go through it. Okay, so for this one here, not like the other one we just got done doing, the x's are negative 1 and negative 5. So I'm going to subtract them on the bottom here. To figure out the y values go along with them, I got to do g of negative 1 and g of negative 5. So again, for g of negative 1, I'd come up here, replace negative 1 in place of the x. That'd be negative 1 plus 3, which is 2. 2 squared is 4, plus 5 is 9, so this would be 9. G of negative 5, I'd put negative 5 in here. Negative 5 plus 3 is a negative 2. Negative 2 squared is 4. And 4 plus 5 is 9. So both of these produce 9. Negative 1 minus a negative 5 becomes a positive 4. Well, 9 minus 9 is 0, and 0 divided by anything is just 0. So this means that the average rate of change is nothing, which if I saw a graph of this, I would see a horizontal line between these two given points. Let's interpret a table a little bit now on this one. So you're given that P of n models the price in dollars of a pack of n bulbs, light bulbs actually, at a certain store. So there's your table of values there. When does the price of a pack increase faster? Between 4 and 10 light bulbs? Between 10 and 12 light bulbs? Or is it the fact that the price increases at the same rate over both intervals? So take a moment, see which is the correct answer, and then we'll go through it. Okay, so to answer this question, we again have to calculate the average rate of change. And the average rate of change, to calculate these again, I'm just basically given ordered pairs. I'm given like a table again. Here's my n value, here's my p of n value, or my y value. So it's like my x is like my y. So I'm going to do, between 4 and 10 light bulbs, I'm going to be doing, the average rate of change is going to be the 25 minus 12 over the 10 minus the 4. So that's where I got those values from. And when I work that through, I get 13 divided by 6, which is about $2.17 per bulb. So the average price per bulb, when I'm looking between 4 and 10 light bulbs, or buying between 4 and 10 light bulbs, is about $2.17 per light bulb. When I'm looking buying between 10 and 12 light bulbs, I'm going to take these values, 28 minus 25 over 12 minus 10, which gives me 3 over 2, which is about $1.50 per light bulb, or 1.5. So it's $1.50 per light bulb between 10 and 12 light bulbs. So it seems like if I buy more light bulbs, the price per light bulb decreases. So when does the price of a pack increase faster? The price per light bulb, which means that the price of a pack should also, change accordingly, is going to certainly be higher between 4 and 10 light bulbs. So they certainly are not the same rate of change, but you know, uh, certainly it was a higher amount per light bulb for this. So let's try one last one like this. Vera uploaded a hilarious video to a funny videos website. V of t models the number of views the video got as a function of time, t, in hours. And there's the table of values there. When did the number of views increase faster? Between 5 and 10 hours since Vera uploaded the video? Between 10 and 20 hours since Vera uploaded the video? Or the number of views increased at the same rate over both intervals? So take a moment, see which one of these is the correct answer, and then we'll go through it. Okay, so again, much like we did on the previous one, this represents the number of hours since she posted it, and this is the number of views it got at those various times. So if I'm looking for the average rate of change between this 5 and 10 hours, I'm going to take these values here and subtract them on top, and have the subtraction of these two values on the bottom. So the average rate of change for between 5 and 10 hours comes out to be 110 over 5, which is 22 views per hour. So on average, between hours 5 and 10, we had 22 views per hour. Between hours 10 and 20, we have 500 minus 180 over 20 minus 10, which is 320 over 10, which is 32 views per hour. So we can see that the views per hour is increasing between these two values. It's going up higher. It's going up by 10 additional views per hour. So obviously this would be, the selection where they increased faster. And that is the end of this video. If you have any further questions, please make sure to reach out to me. Until next time, have a good day.